Welcome back, Quant Files, to INST 314 Statistics for Information Science. We're continuing our journey on this 4-video series for descriptive statistics and charts, and in this third video, we're entering into the second half of the video series on the charts, which in this case really expands to tables, charts, graphs, and those other sorts of visual pieces of information that we can condense descriptive statistics in such a way that is more easily digestible to our readers. So in the introduction to graphs and charts section, we're going to be looking specifically on the types of graphs and when to use them. And in the next one, we'll be looking at the different quality of some of these tables and graphs. So let's look first at the univariate summary statistics that we can be doing graphically. And I'm going to show you the first one that I don't usually want you to use in this class, and that is the pie chart. The pie chart is the infamous fan child of most business rooms and fun presentations, because pie charts are fun. They work with categories, and we like wedges. They look like pizza and pies, and you can color them, but they're often done poorly, and people aren't very good at interpreting circles and the areas of circles with them. So it's good for when you only have a few categories, bad when you have them, many of them, and we don't see them visually very well. What's even worse is if a three-dimensional pie chart. Don't ever produce three-dimensional graphics in this course unless you're specifically working with three-dimensional data. That's going to work well with this. If you're just making regular plots and charts, don't make it three-dimensional, because those extra dimensions throw off the scale and the aspects of your data and send the wrong message. So certainly no 3D pie charts. The next one is the histogram, the popular favorite of when we're looking at one quantitative variable, and the R will structure the data you have into what we call bins. So in this case, we see age ranges. There's a column for 20 to 29, 30 to 39, 40 to 49, etc. Those bins were automatically created when the histogram was set. You do have control in the R code to set the size of bins that you want to use. Otherwise, it generally puts something out there for you. And this particular one, we're looking at the age of lottery winners. Then we can have histograms that are multimodal. We were saying before that every hump that you have on your histogram is a mode to it, and so what we have here are a lighter color, sort of pinkish orange for women, and a purpley blue for men, and the area that they overlap has a sort of purple color in the middle. And we're treating this as a bimodal single chart because of the two different humps that are there. This is technically a bivariate graphic since the histogram is for height, but the coloration we add makes it a bivariate chart in this particular case. I want to show you this one here. I mentioned before in the previous summary statistics with descriptives this idea of skew, and skew is where we can see this graphically speaking at least, where one tail of the histogram swings way out into one particular corner to the left side or the right side as they go. When the tail is long and out to the right, it has right skew or positive skew, and the hump leans to the left. If the hump leans to the right with a long tail going out to the left, then it is left skew or positive skew. And we can see some of these with different sorts of humps in these graphs here. So in the upper left corner, we have the unimodal symmetric. This is the single nice curve that we have that we're going to come back to when we talk about normal distributions. But when I say unimodal, it means it only has one hump and symmetric, so it's not really leaning much to the left or to the right, and the tails are the same length. Looking across to the right, we have the unimodal right skewed, so we have the one big hump for the unimodal, and the tail goes far out to the right side. This is an extreme exaggeration and kind of looks like a ski slope. The unimodal left is just a mirror image of the unimodal right. It still has one large hump up on the right side and the long tail sticking out towards the left. Bimodal symmetric is when we have, similar to our unimodal symmetric, so there is not too much lean to the left or the right, but we have at least two distinct humps. Well, not at least. We have two distinct modal humps there. Looking towards the center, we have the multimodal symmetric plot. So again, the modes have not too much lean to the left or the right, but we have three or more humps in that distribution there. And then we have what we call the bimodal skewed, where we have a combination of both left tail or right tail skew and at least two humps here for the bimodal. So in this case, that skew is going out to the right. When we're looking at measures of central tendency and dispersion as they relate to some of the graphs, if it's going to be skewed or not and which ones are which, think about it with the shape. The median and the IQR are based on percentiles, whereas the mean and standard deviation are based on averages. This is going to cause a relationship when we are talking about the skew and where the high ends are, and the median is more robust against skew than the mean. So if we have symmetric distributions, then we will tend to use the mean for the measure of central tendency. Standard deviation goes with that. When we have skew, we're going to use the median and the IQR to discuss the spread. So what we're going to see then in the effect is you can have a right tail distribution. That's when you get that long tail out to the right. Your median is going to be less than your mean. Think about this if you have high incomes. Very few people have lots of income, and so your average income that you report is going to be a higher number than the median income. Left tail distributions, that means we have the long tail sticking out to the left, and in this case the mean is less than the median. And if it's symmetric, they should be about relatively equal to each other. Let's go ahead and look at housing lot size. And on the histogram here, we have the size of the property in square feet and the frequencies of those homes on the y-axis. So I'd like to know which of these is going to be greater in the median property size or the mean property size. Think about that for a minute. All right, so this is very similar to what I just mentioned a moment ago with an income. We have very few homes that are very large, but those few high numbers are going to drag the mean closer towards them. They say, I count, I'm important, and it biases your mean, it skews your mean. So the median would be the more robust option and be more accurate, just to kind of identify where the majority of the observations are at. Another type of useful plot is what we call a box and whisker plot. And a box and whisker plot has many different parts, so we have these all labeled out for you. The box in the middle are the quartiles. The first box is the 25th, it's the first quartile or the 25th percentile. And the other end of the box is the third quartile or 75th percentile. The line in the middle is the median. The whiskers on the outside of that box represent the extra amount of distance that goes towards what they consider a maximum and minimum values, and those are 1.5 times the IQR. Remember, the IQR is third quartile number minus first quartile number. That's the IQR. So you take the IQR, multiply it by 1.5, and then add that to the high end and add that to the low end of the first and third quartiles, and that will give you the length of the whiskers. That's your general idea for where the majority of your data should be at. Anything outside of those that are high values or low values become what we call potential outliers in your data, and they'll appear as dots outside of the box and whisker. Two other little things we want to talk about here are using QQ plots and histograms to visualize what we consider some sense of normality. QQ plots are a way to get one variable to say how much do we actually have and how much should we have theoretically based on these distributions. And if it's a relatively equivalent amount, pretty good at modeling itself, then all of those dotted observations will fall upon a trend line that appears in the data. This example here, we have the far right side of the plots are pulling far away from that line of normality there. So this is not going to be so normal. Whereas the one on the right side here, the histogram of a duration variable, we've overlaid a modality curve, a line curve, onto this histogram here. And we can see that it has generally speaking, one nice mode, but it has sort of a long tail that skews out to the right to capture those high-end values. So let's take a moment and look at bivariate summary charts and see how some of these look. With these, we're going to have the bar charts up first, and the bar charts or bar plots can be vertical as they appear on the left or horizontal as they appear on the right. The right one, I've done a slightly different version for you to look at, and that's what we call the stacked bar charts. So the vertical one on the left, your groups are next to each other, and you can see which one is taller relative to the next one, or shorter relative to the next one. Whereas in the stacked bar, we put all of those different groups into one common bar, and then we color them differently so you can see where they are and which ones they're standing at. Now these are nice because you can have more groups into your plot without as many small bars for each one, but it makes it a little more difficult because then when you want to visualize this, you don't have all the blue groups and the orange groups and the gray groups starting off on the same foot. You kind of have to give a quick estimate for their size. Then we have what's called a mosaic plot. And mosaic plots can be used when you have two categorical variables with each other, or a categorical and a numerical. And what it will do is adjust the size of the columns and the length of those to kind of be more of a proportional representation on the amount of data that are in there. So the largest amounts, what appears to be in this data set here, of homes and that have basements and how many stories those homes have. And so homes that do not have basements and have the first and second story look like they're the predominant force in this particular data set. And there's other things we can extrapolate out as well. We can also do those box and whisker plots, but you can, when you're in bivariate mode, you can have multiple box and whisker plots, one for each category. And these we use when you have a numerical variable and a categorical. Specifically, categorical is your grouping variable, and your quantitative is the one that you are measuring these sorts of number changes on. In this case, the chart that we're looking at is modeling 3 different age groups by their blood pressure. The scatter plot is the traditional one where we have 2 number values with each other. So in this case, we have home prices versus their lot size, or how big their home area is, and the price is in 1987 Canadian dollars, and the lot size is listed in square feet, and we have this sort of cloud of data points. And remember what I was saying before about correlations. The more these appear towards a single line, the stronger the correlation will be. And then this one looks like it's in a generally upward tick, so it'd be more positive. So which one is better? Well, that's really going to depend on what it is you're trying to portray, as well as the kind of variables you have. Scatter plots use 2 quantitative variables, and so you're not going to be able to really use a categorical variable in a scatter plot. It just doesn't work very well. And so if you want to know which type to use, really have a good sense and understanding of your variables, their types, the counts in them, understand the summary statistics before you make your graphics, and it'll help you go a long way. And this will wrap up the introduction to the charts component, and I'll see you in the last video we have on presentation quality graphs and charts.